All right, guys, welcome to today's class. Today we're going to continue where we left off. So let's get started with 2.39. Is it possible for two exterior angles of a triangle to be supplementary? Why or why not? So basically, how do we approach this? Well, notice that if we draw a triangle, we want to consider the exterior angles, all right? We'll notice that they all sum up to 360 degrees, all right? And they must be supplementary, all right? So you must have one be obtuse or less, and one must be smaller, all right? So how do we do this now? Well, notice that we can have these two angles to be A plus B plus C. That's 180 degrees, right? Now, one of these is A plus C degrees, and one is A plus B degrees, right? Since it's going to be 180 minus C and 180 minus B. Adding this up is gives you 2A plus B plus C. Now, we have an A plus B plus C, which is 180 degrees, but we have an extra A, so it's not possible for them to be supplementary, all right? So the answer is no. Now let's move to 2.40. Three lines, straight lines intersect at O, and COD is equal to DOE in the diagram below. Ratio to COB to BOF is 72. What is the number of degrees in COD? I'll let you guys have a try on this question and tell me through chat. All right, let's get started with this question now. Now, what is the number of degrees in COD? All right, so COB to BOF is 72. And we know this is a straight line, all right? So we have to know the total number. These are 7 parts to 9 parts. Adding this up is a total of 9 parts. So 9x, say that x is the number of parts, is x is 1 part. It's going to be 180 degrees. This is a straight line. Or x is 20 degrees. So you then get this is 140 degrees. And this is uh 40 degrees. Now what is COD? We want to find COD. And we know that COD is equal to DOE. Alright? So it's bisects. Which means that it also bisects BOA and AOF. These are the same angles. BOA and AOF are the same because COD is equal to DOE. These are two straight lines and they get bisected. So, answer is 20 degrees. This is 40 divided by 2. Alright? Now let's move on to 2.41. Find W in the diagram below. I'll tell you try this question and tell us through chat. All right, let's get started with the question now. So, how do we approach this? Well, notice that W is in the diagram below, and we know that we have 360 degrees, all right? These are 360 degrees. But I also want to know that this is the parallel lines, all right? We want to know that we know that this is parallel lines. So let's draw this transversal. Extend everything and draw these lines, all right? Now it's much more easier to see what we want to do. All right. We know that this angle is going to be equal to this angle since it's transversal, but we can easily find that angle since this is just going to be 95 degrees. All right. This is 95 plus 85 is 180 degrees. Now it comes so simple to find what this angle is, which is just 50 degrees. You can just add it up. So it should be 40 degrees. My bad. This should be 40 degrees. So it means this is 40 degrees and this is 90 degrees. All right. This is just pure angles. All right. To recap, we just extended these lines and then saw that we can make triangles. So we got 45 degrees, 95 degrees. Find the missing angle. That's going to be 40 degrees. All right. Run it back. 40 degrees. Now from there, we can put 40 degrees over here since these are the same angle. They're alternate interior angles, or of course, alternate angles. I'm pretty sure it's like that, like corresponding or something. But 90, then we can use 180-degree formula to get that. This is 90 degrees. So W is 90. Oh yeah, W is not 90 degrees. Yeah, W is 90 degrees. My bad. Yeah, since this is the supplementary angle, so it's gonna be 180 minus 90, which is just gonna be 90. All right. Now let's move on to 2.42. Yep, that worth works. One angle of a triangle is 20 degrees. If the largest angle of the triangle has 6 times the measure of the smallest, what are the angles of the triangle? I'll let you guys have to try this question and tell me to chat. All right, let's get started with this question now. One of the angles is 20 degrees. If the largest angle is there's 6 times the measure of the smallest, what are the angles of the triangle? We already know that one of them is 20, and that's not going to be the smallest. We have two assumptions here, all right? That this is the smallest angle, and so this just means that the other angle is going to be 120, right? Since that's the smallest angle. So we're assuming that. So if that's the smallest angle, that's 120 degrees, and we find that the other angle is going to be 40 degrees. That works. But if we assume that the other angle is the smallest, then we have 7x plus 20, equal 180 degrees. 7x is equal to 160 degrees, which is more than 20. This doesn't work. You can try it out. So this is telling you that this is the only valid configuration. So it's just 20, 120, and 40. Let's move on. The measures of the angles of the diagram below are as marked. Find C. Let's get a try on this question and tell me answer to chat. Well, let's get started with this question. So to measure these angles with a marked, find C. This is just pure angle chasing. This is going to be 180 minus 4x, supplementary angles. We can find this angles C very easily, but we want to find X first. This is 180 minus 4x. This is 180 minus 2x. Note that 180 minus 2x plus 180 minus 4x must be equal to 180 degree. No, oh, hold up. No, that's not true. Oops, I'm sorry. Make sure you don't see things off the bat. Make sure you read the question and look at the diagram very carefully. So these are parallel. What can we do with these parallel lines? First thing that comes up to my mind is transversals. That's right. We're going to do a transversal. Now that this angle should be equal to this angle. That should be true. All right. And then we should have 2x to be equal to. Well, what is this angle? This angle is going to be 180 minus 4x plus 3x. It would be 180 minus 3x plus 180 minus 4x. Or just x. That's just x. So we have an x over here, and 180 minus 4x or 180 minus 3x is equal to 2x, or finding is just x is equal to 180 minus 5 or 36 degrees. So the answer to this question is just 36 degrees. Alright? So this is practice angle chasing, right? Now let's move on to 2.44. The three angles of the triangle have a measures A equals x minus 2y, B equals 3x plus 5y, and C equals 5x minus 3y. Find x. Also, have a try this question and tell me your solution. Let's get started with this question now. We have three angles, measure x minus 2y, 3x plus 5y, and 5x minus 3y. Find x. Notice that this is an entire group that's sum up to 180 degrees. Notice that the y's cancel out freely, so we can just only look at the x's. It's going to be 5x plus 3x plus 1x, or 9x is equal to 180, or x is 20 degrees. And that's our final answer. Now let's move on to 2.45. It is not possible to define the value of y in the previous problem from the given information. What if you are also told that one of the angles of the triangles is 10 degrees? Now is it possible to compute y? What are the possible positive values of y? I'll just start to try this question and tell me through chat. Let's get started with this question. It is not possible to find the value of y in previous problem. What if you told to find the angle of the triangle is 10 degrees? Is it not possible to compute y? Well, the angle is 10 degrees. Yes, it's gonna probably. Well, that really just depends on how you work on this, all right? All right, so if you let one of the angles be one, you want the smallest one, and you can use, obviously, you can use any angle to be 10, but you're gonna find out that only one of these angles work, and it's gonna be make it y equals 5 degrees. All right, I won't work it out, but you can let case work and let one of these to be 10 degrees, or this one 10 degrees, and then you can case work it out. I'm fine. Why? Now let's move on to 2.46. Show that if a transversal cuts two lines such that the same side interior angles are supplementary, then the two lines are parallel. I'll also gonna try this question and turn us to chat. Let's get started with this question now. So, show that if a transversal cuts two lines at the same side interior angles supplementary, then the two lines are parallel. So we know that this is going to be parallel if and only if these angles are the same. I mean, if these angles are the same. Which follows because these same side interior angles are supplementary. This means that these angles are the same because these guys are angles supplementary, so this one's also supplementary. This angle, these guys' angles must be equal. Alright? Now let's discuss AASA and AAS congruence. I'm pretty sure you guys all know it. It's just angle side angle and the applications of it. But so let's move on. Let's you guys have a chart on 2.12. In the diagram, AD is going to BC and AD is parallel to BC and E and F are on AC so that ADE is equal to CBF. Prove that AB is parallel to CD and DF is equal to EB. Well, let's get them trying this question in terms to chat. Let's get started with this question. Now, in the diagram, AD is going to BC and AD is parallel to BC and E and F are on AC, and so that AD equals CBF, and prove that AB is parallel to CD and DF is equal to EB. Now we go hunting for equal angles and to use to prove that AB and CD are parallel. In this diagram, it's pretty obvious that it's parallelogram. Parallelogram. So we start marking the angles by we know are equal, and we have a pair in our original diagram, and we can add DAC due to ACB due to AD is parallel to BC. We're given. All right. All right. So now we can find some congruent triangles. Since AD is going to BC, DAC is going to BCA, and AC is going to AC. This comes from logic, and we have CAD is going to ACB by SAS. Yep, you can see it. That's true. Therefore, DCA is equal to AC, so AB is parallel to CD. We can also have another pair of congruent triangles, DAE equals BDCF by ASA. So it's not immediately clear how this will help us prove BE equals DF. So we go ahead and mark the new equal lengths we know from our new triangle congruence. Focusing on segments BE and DF, we look for congruent triangles that have these at sides. We start by looking for triangles we know something about, which leads us to ADF and CE. And we already have a side and angle, and that AEF is AE plus EF equals CE plus EF, or CE. Just a rearrangement, which gives us a second side. So ADF is equal to CBE by SAS. Finally, we conclude that DF is equal to BE. We could also have used SAS to show that DFE equal to BFE, and then BEF. So DF is equal to BE. So what's the idea in this question? So we basically write down what we see as we move on and label the diagram. Can you draw a shape on the paper that has dimension 3? That is a dimensional 3, I guess. 3-dimension figure, it's a cube. So I think I can do it. Anyways, the whole idea is just to find similar triangles to prove that the angles are correct. And by angle chasing, being parallel will follow, right? So that's the whole idea of these questions. Just showing how we can angle chase and prove stuff. I'll do it in a later class, alright? But anyways, this is it for today's class. Hope you guys have a wonderful weekend, and I'll see you next week. Bye. Yeah.